Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be solving Irodov's 1.25. The problem statement is given here. There is a particle that moves in xy plane such that its x coordinate and y coordinates vary with time in a certain given fashion. The equations have been given here. X is equal to at, y is equal to at into 1 minus alpha t, where it is given that a and alpha are both more than 0. First part is asking us to find the equation of point's trajectory. Y is a function of x. Now, if x and y are known and he's asking us to find out y as a function of x, then he wants us to eliminate time from these two equations. So for part A, please note that t can be written as x divided by a, and then it can be substituted into the equation for y. So y's equation is y is equal to at minus a alpha t square, opening up these brackets, and then in this equation we will try to substitute t is equal to x by a at both these places, and you will end up with y is equal to x minus alpha x square by a. This is the equation of trajectory. This equation looks like equation of a parabola. The standard form of a parabolic equation is y is equal to 4ax square or y minus y naught is equal to 4a x minus x naught square in case of a vertex that is not origin. So if you have a look at this equation here on the top, then this equation can be expressed as minus alpha by a into x square minus ax by alpha. This is the first step, trying to isolate the x square term. Next, the second term should look like 2 times the first term times the second term. So clearly the second term should be a by 2 alpha. Then we should have a third term that should be this term square, and because we are adding this term ourselves, we need to subtract it also, so that there is overall no change in the equation. So that is minus a square by 4 alpha square. And then you will see that this equation can be expressed in a square form, minus alpha by a into x minus a by 2 alpha whole square, plus this term here is in fact the product of the term outside the brackets and the last term inside here. This term goes over to the other side, and we have y minus a by 4 alpha is equal to minus alpha by a into x minus a by 2 alpha whole square. This is a shifted parabola whose vertex is not origin. The vertex of this will be y is equal to a by 4 alpha and x is equal to a by 2 alpha. So this point, and because the constant here is negative, this will have a downward opening section. So this is the trajectory of the particle. This is a plot of the trajectory of the particle. In the second part of this question, he is asking us to find out the velocity and acceleration of this point as functions of time. So if you have a look at the expressions that he has given us, he gives us x as a function of time, y is a function of time, with the help of which we can find out dx by dt and dy by dt. And then this is vx, dy by dt is vy, and then the velocity is vx I cap plus vy j cap. Magnitude of velocity is square root of a square plus a minus 2a alpha t whole square. And similarly, we can find out the acceleration vector. Acceleration vector can be expressed as ax I cap plus ay j cap. So ax is 0 here because vx is a, which is a constant, and ay can be found out. Ay is minus 2a alpha. So these are the vector expressions for the velocity and the acceleration. Then in the C part, he wants us to find out the moment t naught at which the velocity vector forms an angle of pi by 4 with the acceleration vector. So velocity vector and acceleration vector, which are found in the B part, make an angle of 45 degrees with each other. We can write this whole equation in terms of the dot product. So v dot omega, omega is the acceleration vector here, is mod v mod omega cos pi by 4. This is true at a time when v makes pi by 4 with omega. So if you have a look at this equation, we can say that v dot omega will be the dot product of only their j components, which is here. I components will give you 0 because omega expression does not have a I component. And mod v mod a cos of 45 degrees, that is 1 by root 2. Solving this equation will give us t is equal to 0 or t is equal to 1 by alpha. So there are two values of time that we obtain, and at these two values of time v and omega will be at 45 degrees to each other. So this was a very simple problem. I hope you have learned something from my channel here, and I hope that you will be updating yourself with my other modules also. See you.